Hello guys, thank you so much for watching my video. Today I would like to show infinite sum of zeta function. Okay, Riemann zeta function. Then is sum from n equal to 1 to infinity. Zeta of 4n minus 1 is 7 by 8 minus pi by 4 times e to the 2 pi plus 1 upon e to the 2 pi minus 1. Okay, this is what we are trying to prove. So let's get proof it. Now S, let me say S is or this or sum. Okay, sum from n equal to 1 to infinity. Zeta of 4n minus 1, which is sum from n equal to 1 to infinity times zeta definition is sum from k equal to 1 to infinity 1 over k to the 4n minus 1. Okay, this minus 1 is here, and this summation, this part is the definition for zeta function. So now S is equal to sum from n equal to 1 to infinity, sum from k equal to 2 to infinity 1 over k to the 4n plus 1. This plus 1 comes from this one. Okay, so when k equal to 1, so it will be 1 to the 4n, right? It is just 1, so 1 plus 1 minus 1. So why we did this? Because I am trying to cancel this too, to get cancel out. Okay, so you get the sum from n equal to 1 to infinity, sum from k equal to 2 to infinity 1 over k to the 4n, which is now interchanging this to sum. So sum from k equal to 2 to infinity, sum from n equal 1 to infinity 1 over k to the power 4n. Okay, so if you look at this one part, this is nothing but our geometric series. Okay, GP, geometric series. Okay, this is geometric series with common ratio is what? 1 over k to the 4. Okay, so our common ratio is 1 over k to the 4. So using geometric series, you get that this one is nothing but a, right? A upon 1 minus r, right? A is the first term and r is the common ratio. So using that, you get sum from k equal to 2 to infinity of, this is a. Okay, this is first term here. If you see the first term, it will be k to the 4. So 1 over k to the 4 upon 1 minus 1 over k to the 4, and this is the common ratio again. Okay, now if you simplify this, you will get sum from k equal to 2 to infinity 1 over k to the 4 minus 1, right? So using our algebra, so which is sum from k equal to 2 to infinity 1 over k to the power 4 is same as k squared to the power square minus 1 square, and 1 is 1 square. Okay, which is applying the a square minus b square, so you get sum from k equal to 2 to infinity 1 over k square minus 1 k square plus 1. Now if you take the partial fraction, then you get s equal to half of both are half is there. Okay, half of sum from k equal to 2 to infinity 1 over k square minus 1 over k square plus 1. Okay, this is the partial fraction for this. So which is equal to, now separating them, 1 over 2 sum from k equal to 2 to infinity 1 over k square minus 1 minus 1 over 2 half sum from k equal to 2 to infinity 1 over k square plus 1. Okay, this one you can apply again, k square minus 1 square, which is k minus 1 k plus 1. There will be in the later part, we will do that. Now let's find out what is this. Okay, now let's consider our hyperbolic cot x. Okay, so cot hyperbolic of x is, I have already done this one, the partial fraction expansion for cot hyperbolic of x. Okay, you can check out that is 1 over x plus 2 times sum from n equal to 1 to infinity x upon x squared plus pi square n square. Okay, now we are trying to get this one, so putting x equal to pi, so cot hyperbolic of pi is 1 over pi plus 2 times sum from n equal to 1 to infinity pi upon, here this will be, x will be pi times pi already, so it will be pi square, right? So pi square we will get common here, pi square, and 1 plus n square, right? So this one and this 1 pi will get cancelled. You will get 1 over pi plus 2 over pi sum from n equal to 1 to infinity 1 over 1 plus n square. And simplify this, 1 over pi plus 2 over pi sum from n equal to 1 to infinity 1 over 1 plus n square. This is exactly what we are doing here, right? But this sum is from 2, this sum is from 1, okay? You can change that one also. So here pi, so multiply by pi, you get pi. Code hyperbolic of pi is 1 plus 2 times the sum from n equal to 1 to infinity, 1 over n square plus 1. So now pi, code hyperbolic of pi is 1 plus. Now for n equal to 1, okay, this is 1 square plus 1, which is 2. So it will be 2 over 2 plus 2 times sum from n equal to 2 to infinity, 1 over n square plus 1. This one is exactly the same as this one, right? Now finding out simplified sum of them, then you will get sum from n equal to 2 to infinity, 1 over n square plus 1 is pi by 2 cot hyperbolic of pi minus 1. Okay, now we can put this in or this one now. So or s is equal to half of sum from k equal to 2 to infinity, 1 over this one, k square minus 1 is same as k minus 1, k plus 1 minus this one, okay, and 1 by 2 times this sum is nothing but this one. So it will be pi by 4 cot hyperbolic of pi plus 1 half, right? Now now s equal to, now if you take this partial fraction, okay, 1 over k minus 1, k plus 1, then you'll get 1 half times 1 over k minus 1 minus 1 over k plus 1. Okay, the partial fraction for this one is this one. So this 2 and this 2 will multiply, so it will be 4, 1 over 4, sum from k equal to 2 to infinity, 1 over k minus 1 minus 1 over k plus 1 minus pi by 4 cot hyperbolic of pi plus 1 by 2. Now s is equal to 1 over 4. Now if you see this 2, this sum will start from k equal to 2, so it will be 1, right? So 1 it will be 1 plus, if it is 3, it will be 2, 1 by 2 plus 1 by 3 plus 1 by 4 plus and so on. And again if you check this one, so sum from k equal to 2, it will be 1 by 3 plus 1 by 4 plus and so on. Now looking this one, so for this, these are common, right? So we are going to take out these two from this sum, this first sum. So it will be 1 plus half plus sum from k equal to 4 to infinity, 1 over k minus 1 minus sum from k equal to 2 to infinity, 1 over k plus 1 minus pi by 4 cot hyperbolic of pi plus half. Now this 2, this will start from 4, so it will be 4 is 3, right? 1 by 3 plus 1 by 4 plus and so on, and this is will start from 1 by 3, right? Remember these two are the same thing but with opposite signs, so cancel out them, right? And then continuation for this one is here. Now these two already get cancelled, so you get s is equal to 1 by 4 times, so if you simplify this, 3 by 2, right, plus 1 by 2 this one minus pi by 4 cot hyperbolic of pi, which is 3 by 8 plus 1 by 2 minus pi by 4 cot hyperbolic of pi. You will get s equal to 3 into 3 plus 1 into 4, this one, okay, upon 8 minus pi by 4 cot hyperbolic of pi, which is 7 by 8 minus pi by 4 cot hyperbolic of pi. This is near to our answer, right? 7 by 8 is we get already here, negative pi by 4 we get already here, so we have to change this cot hyperbolic of pi to this one, okay? Now seeing the definition of cot hyperbolic, so cot hyperbolic of pi is nothing but cos, okay, cos hyperbolic of pi by sin hyperbolic of pi. So actually the here will be 1 by 2 and here will be 1 by 2, they will get cancelled out, okay? So cot hyperbolic of pi is 1 by 2 times e to the pi plus e to the negative pi, and sin hyperbolic of pi is 1 by 2 times e to the pi minus e to the negative pi. So half will get cancelled. Now multiply both numerator and denominator by e to the pi, you will get e to the 2 pi plus 1 upon e to the 2 pi minus 1. Therefore our s is 7 by 8 minus pi by 4 cot hyperbolic of pi is nothing but 7 by 8 minus pi by 4, and this one we get e to the 2 pi plus 1 upon e to the 2 pi minus 1. Then is what we are getting here, this one, right? So our sum from n equal to 1 to infinity, zeta of 4n minus 1, which is 7 by 8 minus pi by 4 e to the 2 pi plus 1 upon e to the 2 pi minus 1, or you can rewrite this as 7 by 8 minus pi by 4 cot hyperbolic of pi. Same thing, okay? This is what equals. So this will be for the proof of this infinite sum of zeta function, okay?